Hello and welcome to Additive Insight, the original additive manufacturing industry podcast brought to you by TCT Magazine. I'm Laura Griffiths, TCT Head of Content, and on this episode, I'm joined by Joe Allison, a 3D printing veteran and the latest inductee to our prestigious TCT Hall of Fame. Joe has seen and shaped over 3 decades in the additive manufacturing space. Having started out as a process engineer at 3D Systems in the late 80s, shortly after, Joe founded his own company, Solid Concepts. Here, he developed industry-first tools such as automated support generation software for stereolithography, and grew what would later become one of the world's largest suppliers of 3D printed parts. Today, Joe continues to influence the sector as a founding member of 3D Ventures and CEO of Gentle Giant Studios. Throughout our conversation, we discussed Joe's impact on the 3D printing industry, lessons learned along the way, and the moments of brilliance that have kept and continue to keep him excited by these technologies today. If you like what you hear, don't forget to subscribe wherever you get your podcasts, and for more additive insight, head over to tctmagazine.com to receive the biggest 3D printing news stories of the week delivered straight to your inbox with our Additive Insight newsletter, or get yourself a TCT executive membership to receive our global print magazine, exclusive features, bonus podcasts and newsletters, and plenty more. We start the podcast with the same question every single time. We'd love to know, what was your light bulb moment with additive manufacturing? Do you remember the first time you either saw a part, a 3D printer, the first time you got really excited by it?
Yes, I remember it vividly, but I want to give you the long answer is
Mhm.
not just what was the aha moment, why was it an aha moment for me when I
Mm.
first saw my first 3D printer? And so when I got out of college with mechanical engineering degree, I had two choices of places to work. I had an offer from Rocketdyne, and maybe I could have been that sounded like fun, being like a
Yeah.
scientist or engineer. And I actually wanted to do that. And I had one at a company called Memorex, and they made data storage. So they were a computer company. And when I looked at Rocketdyne, they had this big bullpen full of drafting tables, and that's how engineers started back then.
Mm.
And at Memorex, because they were in data storage and then computer business, they had the state-of-the-art CAD CAM system back then. It was called an Applicon. And it was about $250,000 a seat. And the guy said I could work on that. And that was just that closed the deal because I had a couple computer science courses in college. I loved computers. And that set my career going down CAD CAM. And of course, computers prices per seat and CAD CAMs came down quite a bit during that period. And I spent 4 years in that. And to make a longer story shorter, ended up in pre-sales applications engineer at that time. And so being in pre-sales, I went to a sales conference called AutoFact every single year. And I knew I needed a change at the time when the first 3D printer, the first commercial 3D printer at SLA1 was there. 3D Systems was announcing it, and they were on the downstairs floor,
Mm.
um, where usually the big companies, you didn't even go down there and look at that stuff.
Right.
These were small
The
startup companies.
basement.
But that's what I was looking for, a small startup I could sink my teeth into. I went down and I took one look at it. And that was my aha moment. And when I got back, I called my headhunter and I said, I want a job there. And he said, you won't believe this. I just got off the phone with him. They have 3 openings that are perfect for you.
Wow.
And within the week, I had an interview and an offer letter, submitted my resignation, and moved on to 3D Systems.
So when you got your start then at 3D Systems, this is 1988, right?
Yes.
And when you started there, the technology is obviously incredibly new. Can you talk to me a little bit about what it was like? Just give me a sort of glimpse into those early days there, getting hands-on with the new technology. Was it an opportunity to be creative? Was it exciting?
I think it was everything, all of those things you just said. It was everything you would expect at a startup. It was like the Wild West.
Mhm.
There wasn't real clear plans of who's supposed to be doing what, but you knew what your job was. So figure out what to do, not just how to do it. And it was just crazy. You got to just look at the technology and figure out what it needed. The first thing being a startup, too, 3D Systems had just outgrown their startup building in Sylmar. So I had to wait a week till they had this new facility, and there was nothing in it. So we had to go buy catering tables, buy computers, set them up, and do things from scratch. But the early days of SLA were you try and build a part on it, and the green strength was so bad, you'd pull it up out of the vat and it would just collapse.
Right.
And we didn't know any better, but we would just reach in and try and get the pieces. Because back then, we didn't know that the resin was really bad for you. But there was just so many opportunities to do things, and writing software fit my skill set very well. But I did know the whole time that I wanted to start my own business, and I was looking for opportunities to do that. So I did. Within about 3.5 years, I did launch off and start a business.
What made you decide it was the right time to make that jump and start your own business?
As a mechanical engineer, there's limited opportunities to go start your own business. And I saw two very good opportunities. So the timing was there. Um, I also was keenly aware of, if you're going to start your own business, it needs to be something you are in the right position for, you have the
Mhm.
right skill set for, and it's the right timing for. And so I had two different opportunities to do that. And one was write some software with a friend to create supports for the stereolithography machine. And because there was nothing that did that yet. The other one was to start a parts business because the technology was so hard to operate then that it was an opportunity for somebody like me that had spent 3 years in process development and knew it inside now to go do that. So I worked on both those at the same time, and they actually came together at the same time and thus merged into a company called Solid Concepts. The software was Solid Concepts, and the parts business was Laser Fab.
Mhm.
And then when they both launched, we just merged them together and kept Solid
Mhm.
Concepts name.
I feel like we take some of those tools just for granted these days. Like you say, these things just didn't exist at the time then. How do you think that sort of influenced the usability of 3D printing and the accessibility of it?
I think that in a lot of ways, we really influenced the accessibility of it. So, first, let's start with the software that generated supports for
Mhm.
stereolithography. To design a CAD part, this is the final part that someone wants to get out of the machine. That might take you hours or maybe a whole day to design the part. And you needed all these intricate supports to anchor it down to a platform. Otherwise, stereolithography is a liquid vat based 3D printer. So if things aren't anchored down, they just float away in the vat. It took 10 times longer than that. It would take days to intricately design all these little supports to anchor it down so you could print the part. So as soon as we came out with that software, we didn't even have to market it. The salespeople would tell every customer they had, you need to go buy this.
Yeah.
And so that made the technology very accessible.
Mhm.
Uh, and otherwise, you'd buy this $250,000 machine, right? And it would sit there doing nothing for 90% of the time while some guys over there trying to design all these supports. Other areas where we came out with the first 3D viewer,
Mm.
generic 3D viewer, so you could view 3D data from any CAD system, IGES data, and just about any format. And we wrote that because at some point we found that to deal with our customers, we had Pro Engineer seat in house, we had SolidWorks in house, we had Unit Graphics in house, and a CATIA in house. And we finally realized, and then you need specialized talent to be able to run those. We just realized as we were growing it would make sense to write our own generic CAD viewer just for our own use inside.
Mhm.
But then when we were done, we were like, we need to market this. I think that made the technology more accessible because almost everybody bought that. Even our competitors in the parts business would buy from, they hated giving us the business. But it was a good priced piece of software and it served them well.
Speaking of your parts business then, because your company at the time ultimately grew into one of the world's largest suppliers of 3D printed parts. I wonder if you can talk about that growth and building that and maybe share some of your favorite milestones there.
That's a hard one because there were just so many. We're talking about over 20 years, maybe
Mm.
close to 25 years of
Yeah.
doing that. Milestones were the release of the software, getting our first SLA. We had no money at the time.
Mm.
So there's someone who offered us to sell the machine, and we said, we have no money. And they said, I'll take a note on it. So we got our first machine with no money. And that helped launch us off into that business. And that started with stereolithography.
Yeah.
I think other big moments were when we got into SLS next. And I watched SLS very carefully, and the parts coming off the machines were just like potato chips. They were just warped all over the place. It was very hard to build a good part.
Right.
And that's because they were trying to use amorphous materials when they started.
Mm.
And the amorphous materials, they just all the heat difference and all the thermal gradients in them made them warp a lot.
Mhm.
Then a guy named Gideon Levy, who's a friend of mine, he realized that a crystalline material that over a short temperature range goes from a solid to a liquid might work better with this. He threw
Mm.
it in a machine and that changed everything. The parts that I saw come off the machine were wonderful. With any new technology, I'm always looking first for just a moment of brilliance. Then I'll figure out how to process it reliably. Just show me the moment of brilliance so I know I can do it. In the early stages, where yes, we had to spend a lot of time refining the process, all the way to the point where eventually we were making flight certified parts out of it for aircraft.
Mm.
Other big moments. One of my favorite was we were the leader in making stereolithography patterns for investment casting. And couple other things that made us better at that. But one was just we were the first ones to discover let's get all the resin out of the inside with a centrifuge. And I can still picture my wife as I was driving away from the house with her washing machine in the back of my truck. And she didn't understand when I said, I need this for a centrifuge. I said, I'll buy you another. Um, and that gave us an advantage in the quick cast patterns for many years. And then we got into cast urethanes, and then it got so good at that that became a big product for end use parts. And why was that a good fit though with 3D printing? It's not really 3D printing, but
Mm.
it's just great at capturing a master pattern, and then it gives you a variety of materials from it. Then we got into FDM,
Mm.
found that it was great for large CNC parts and would replace those. We got into rapid tooling as well too. That's a different story. We ended up just cutting tools, found it to be easier.
One of the customer stories I wanted to ask you about, because I know it's always the biggest frustration when you're a parts manufacturer and you can't talk about these customer stories, but you were one of the very first third-party suppliers to Boeing for flight certified SLS parts. You mentioned flying parts earlier. Can you talk about doing that in the early days? How challenging was that to get them to accept the parts? What was that sort of process like at the time?
It was brutal. It
Okay.
was brutal. You're talking about, we started out in the business we called it rapid prototyping because that's
Mhm.
all the machine was considered to be good for was
Yeah.
prototyping. And in a short number of years, here we are with the technology, and we're trying to qualify it to make flight certified parts.
Mhm.
And here's how it happened. We got the SLS machine, and we worked and made enhancements to it. We improved the processes. We got very good at making good SLS parts. It seemed Boeing was doing that at the same time. And at the same time, for their use, they were writing a process spec and a material spec is what they need to qualify a special process to make parts with. They were doing the same thing and doing it in house, but they needed to set up an independent third party supplier. They don't really like to make pieces. They don't like to make parts in-house. They like to assemble them.
Mhm.
And when they looked to see who was out there, we had the biggest SLS operation. We had a quality system in place that was probably more mature than anybody's. There was no doubt in their mind so that we were going to be the first one.
Mm.
So naively, we said, yeah, let's do it. And no idea that it must have cost us, I estimated $750,000 to do that. And back then, that was a lot of money for
Wow.
us that we paid out of pocket to get fully certified before we were collecting money on parts. But um, it was a lesson well learned. It was money well spent.
Mm.
At that point, we could say we're an aircraft supplier.
Yeah.
And so that led to making parts for Lockheed Martin, Bombardier, of Airbus. Yeah, it was money well spent, and it was an adventure that was worth it.
Mm. It really sounds like in those early days you had to be so willing to take a risk with this technology and just really just put everything into it to get it to that next stage and make it work.
Yes, and I've been called a risk taker before. I admit that I'm a risk taker, but only up to a certain amount. Not quite enough that you lose the war, just a battle.
Mm.
So whatever the risks are, I'm always looking at them and just trying to make sure this won't put the company out of business. We'll give it a try.
But the company didn't go out of business, Joe. Instead, it was acquired by Stratasys, where you later went on to serve as CEO of its direct manufacturing business. And this was around sort of 2014, very much around what we consider to be the sort of peak hype time around 3D printing. I wondered if you can tell me, did you sort of feel that in your work? Did you feel the impact of that? Did it feel like there was a shift? Was it a positive one?
Uh, that's a good question. We've had three bubbles,
Mm,
and the latest one, I don't know if we're in the crash after a bubble, but that bubble in 2014 was by far the biggest. If you
mm,
go back at the stock prices. And I enjoyed running my own privately held company, but it really got to the point there where after over 20 years, and you look at these companies, then they want to use their big stock price to grow through acquisitions. Just organically is not enough to meet the shareholders' expectations. Um, Myself and a lot of other business owners just couldn't resist it. But afterwards, there was a crash and on stock prices, and now we're working for a public company. You can imagine the stress at all levels within the
yeah.
company. But I think we maneuvered it as best we can. I had a contract to work for them for 3 years. I made
Mm,
many good friends there. At the end of 3 years, I was ready to let go.
right.
Um, and so I left at that point. But I think I left on good terms with everyone. There's no one there I didn't like, even though we went through some very stressful times together.
Right. I can imagine. You are still very active in this industry. Like you said, that was the time to, you were happy to leave after that, but you've done so much since. One of those things is co-founding 3D Ventures, which has seeded over a dozen startups in 3D printing. I wondered if you can tell me what made you want to get into that, because to me that says that you still feel very optimistic about the future of this technology and wanting to really champion like that next sort of generation of additive technology.
I guess there's a number of reasons. One would be boredom. I'm just not, it's hard to go from 100 miles an hour to
Hmm.
zero. And the other one is so I have lots of friends in the industry. And when they bring a good idea, it's hard not to want to help people do something with those ideas.
Hmm.
And I thought that I could do that and it would be a nice part-time job.
Yeah.
But after the pandemic, I got so stir crazy that I just jumped all the way back in. And so me and some other cronies from the industry created 3D Ventures and just formally started funding companies.
Right now, I think you've got one of the coolest sounding jobs in the whole of the additive industry, to be honest, as CEO at Gentle Giant Studios. Loads of our listeners and readers will know of all the great stuff that's come out of this studio. We've seen so many exciting projects. And is this like playtime for you now? You know, you had this sort of period where you were saying you were dying to get back into the industry again and get active. This must just be really fun, and you must get to work on some pretty cool stuff.
Yes, it is the funnest job in the industry. It is the funnest job I've had. It's low stress, as in, unlike making flight certified end use parts, if it looks good, it is good,
Yeah,
as the movie says.
yeah.
And so it's low stress and it's fun. We Well, the things we do there is we create digital data by capturing it with photogrammetry and scanning, and we have digital artists that will create it from scratch or work on the other captured stuff and modify that.
Mhm,
And then we use 3D printing to make physical models of these.
mhm.
Um, but we have stars come through there all the time. I don't
I
want to
bet.
mention any names, right? But we have stars come through there all the time. We have scanning trucks where we go on site and you get to see them filming and you're capturing images of all the stars and things like that. So
Yeah.
yeah, it's just plain fun.
Have you ever been completely starstruck with who's been in the booth?
Absolutely. Yeah, I do get starstruck. I, I'm not one of those people that, oh, it doesn't bother me at all. Talk to them like a
Yeah.
normal person. Yeah. When I'm done, I'm like, what did I just say?
Yeah. Okay, so I know you said you can't really tell us about any particular projects there. So I want to move on to asking you some kind of questions about just to really tap into your experience in the industry, because you have been in this industry for a long time. As you say, we've been through these different sort of like hype periods, and I wondered if you can kind of summarize in the time you've been in this industry, you know, what have you seen as some of the biggest changes that we've had?
Yeah, that's a good question. Well, I think one of the biggest that I've seen in being involved with some of these other startup technologies is it's noisier than it was
Okay.
5, 10 years ago.
Mm,
10, let's say 10 years. You could have the best technology ever, and trying to get people to even read the emails or look at it is
mhm,
difficult. They get bombarded with so much material from new technologies that they just have to close it off and start to put up a filter.
mm,
And so the marketing of a new technology and the sales for startups is much more difficult than it used to be. To me, that's one of the most important changes. So that new technologies have to have a plan for how are we going to get through the noise. And that might be there is a perfect target market to launch it with, perfect application. And you've got a sales guy that knows all the right people to get in there. So they
mhm,
can just call them and cut through the noise and get in,
mhm.
or maybe other ways. But that's one of the biggest changes. In the
Yeah.
early days, if you had a good technology, you just had to show up at Rapid or or AMUG here in the US, and somebody would see it and you're off to the races. And it's not
Yeah.
like that anymore.
Mhm. Do you think that's getting any better? Because I know I've been writing about this technology for just over 10 years now, and I feel like when I used to go to trade shows, there'd be 10, 15 machine launches all in one go. And I do think that's starting to slow down a little bit now, and companies are focusing on more incremental developments rather than launching new technology all the time at people.
I think that might be a lot of the investment money has slowed down going into the
Mm.
industry
Yeah.
because of when the stock prices crash, then the valuations for private equity, private companies and startups, those valuations drop down and the money dries up for some of those because the investment community is looking for bigger, faster paybacks. The 3D printing industry has, even with all the ups and downs, tends to grow at more like 15%, not consistently, but overall 15%.
Mm.
And it's not like software and some medical investments where you could get some high margins and maybe they take off faster.
Mm.
And it's slow and steady, but in the
Yeah.
long run, it is going to continue. to capture more and more applications with more technologies and more materials. And when we look back at this, maybe 30 years from now, you won't see these little blips. It's going to look more like a smooth hockey stick.
And is the industry where you thought it would be at this moment in time? When you think back to where you started, have we progressed to sort of the right kind of speed, do you think? What's your view on that?
I don't think I knew what to expect back then.
Mm.
I was young, stupid, a new entrepreneur. Here's a story real quick. Starting out, I didn't need to know about business because it was a brand new technology and we were making 80, 90% gross margins.
Wow.
And had no idea that they weren't going to stay there
Mm.
until this VP of sales, Eddie Gloin at 3D Systems, he was moving back to the UK. He said, Joe, before I go, I've got to tell you, the gross margins aren't going to stay there. And when he was done telling me they're going to drop down closer to 35%, I think I almost threw up. But I really respected him. And I went back to our people and I said, we have to prepare for this. We need to get even more efficient. And it happened sooner than I had ever thought it would. It happened within just like the next two years after he
Right.
had warned me. And so we were well prepared for that, and it helped us get through that phase. And so I really had no idea. I just knew that it would grow, but I really didn't know that we'd have metals machines. I didn't see that coming. They just used more powerful lasers, and then we had metals machines. But so now I have the experience that I've been watching this for 30 years.
Mm.
One new technology at a time, one new material at a time, championing one new application at a time, and it just keeps marching on. And so that's what I think is just going to keep doing. It's going to
Mhm.
keep growing and growing and taking over more conventional parts. And we'll see that will just happen steadily. And it won't happen at a rate that Wall Street would love to see, like
Mhm.
software does with high gross margins and sometimes 300% growth. It's not going to happen like that.
I'm interested using your time in the industry, your years of experience. Do you have maybe a best piece of 3D printing advice or maybe a little nugget that has always stayed with you that you like to impart with people?
Oh, yeah, I definitely have one. I have lots of those, but
Okay.
the most important one I always like to tell people that are developing 3D technologies is remember, it's three-dimensional.
Mm.
Start small. Because if you double the size of the part, you have to double the size of the machine, typically. Right.
Mhm.
And so if you double that, though, it's double in three dimensions, two times two times. So it's eight times the cost
Mm.
to do your development. The machine's eight times more money that
Mhm.
you have to build for it. And the parts that you're building are eight times as much material. So all your process development costs more. Start small, work your way up.
Okay. And Joe, I'm wondering, do you have an unpopular opinion about 3D printing?
Yes, I have one. And it's probably because of all the money I spent on it, the time I spent in it. Um, it's two kind of combined. One is let's start with rapid tooling. I spent years doing and trying rapid tooling with different techniques, filled plastics, filled epoxies, 3D printed parts, and then shooting plastic into plastic. It just doesn't work well. And
Mm.
when you shoot plastic into plastic, you go to eject the plastic, things break. And so it's not reliable. I know there's people would always show these instances where, hey, look, we shot this part out of here and we got this many pieces out of it,
Mm.
and it's okay. But can you go to a customer when a customer brings in a part and says, okay, can you do this? Well, you really don't know till you try it.
Mm.
And being in the parts service business for many years, I had a saying, if for, for your customers to be happy, you need to be able to reliably deliver a well-defined product. And I never found in rapid tooling where I could really do that.
Okay.
It's all soft. Sometimes they break. But then that gets into one of the ways we tried though, is with the metals that are encapsulated in plastic. So they're
Mhm.
with a binder in them.
Yeah.
So you have to bake the binder out, and then you have a bunch of shrinkage that goes with it.
Hmm.
One of, one of my old bosses, Paul Jacobs, had a saying: shrinkage is the engine of distortion, unless you have a perfectly symmetrical part. Okay. So I don't like the binder jetting for metal parts. You just don't know what you're going to get in the end, um, with asymmetrical geometries, which are 99% of what you want to print.
Mhm.
So those two combined, and I
Okay.
know those are popular. There's still people out there trying to do these, but if you see, Desktop Metal has been beating their head against this for many years now, just
Mhm.
trying to make parts that way. And there's still people out there saying, "Oh, we can shoot plastic into 3D printed parts and plastic parts, filled parts." It's not going to be popular.
Okay. Good one. Well, two good ones actually. And so, Joe, the reason why we wanted to invite you on to the podcast is because you are being inducted into the TCT Hall of Fame this year. So, congratulations. So many of the votes that came in for you really commented on your impact and this pivotal role you've had in shaping the industry. And we've seen that just from this very short conversation, all the different sort of areas that you've had influence. So, how do you feel about being described as a 3D printing veteran? Is that like a badge of honor to you? How does that feel?
Oh, yeah. Yes. To get any recognition is a badge of honor. I'm used to being called 3D printing veteran. And yeah, so I don't have a lot of feelings about that. I'm not used to being called like a 3D printing Hall of Famer. So I'm
Okay.
very excited about that. Um,
You'll be getting a nice trophy for your mantelpiece so that everybody can see that you are a 3D printing Hall of Famer, Joe.
my wife has already said there's going to be no living with you afterwards.
So, just to finish off, I wondered what keeps you in this industry today. You've been through all these different sort of periods of the industry. You've had your fingers in various things. What keeps you here for the long haul? What keeps you excited about being in this industry?
I married myself to this industry many years ago.
Mhm.
It's just hard to walk away from. I'm emotionally tied to it. And it's not just the industry, it's the people.
Yeah.
Just all the people I've worked with, my employees that I worked with, people in this industry that'll be at places like Rapid. It's it's all of those. I still like to be involved. Not at a point where it feels like work anymore, but like to be involved. And to the point, and the other factors too is I still feel like from my experience, I still have a lot I could help people with. And in just doing investments in companies, found that in reviewing it they need advice. And I give consulting to anybody who asks for it, wants it. And I have never charged anybody for it. So I want to share any knowledge I've obtained over the years, and I don't want there to be any impediments in somebody getting some of that advice. And so that's the other reason I stay involved.
And what are you looking for then in terms of what's next for this industry? What have you got your eye? What are you excited about?
I really think that I'm really excited about metals
Mhm.
because early on, when we did our first tests of tensile bars on it, and we saw that, oh, the properties are as good as wrought. I knew it was
Yeah.
going to be big, and it is just continuing to grow. But I don't see plastics doing that yet. It needs it needs a technology that can do amorphous materials, because those are what engineers like to design with: ABS, PC ABS, things like that, and do them accurate with good surface finishes at a very affordable price where it can serve the plastics industry better. There's a lot of opportunity there, and I think that's the next big thing that will happen in the industry.
Well, Joe, thank you so much for taking the time to speak to me today. It's been great to kind of do this quick run through of your career, and congratulations again on your induction for this year.
Thank you so much, Laura.